This is section 3.8, rewriting equations and formulas. The first thing we're going to look at is what a literal equation is. And a literal equation is a special kind of equation that has variables instead of coefficients and constants. Normally we would have maybe an x, a y, and then you have numbers in the equation. But this equation has all variables. So you have ax plus b equals c, where a, b, and c actually represent numbers here. The coefficient is the a, and the constants are the b and c. In example 1, we want to solve ax plus b equals c for x, and then we'll use our results to solve this equation, 2x plus 5 equals 11. Now if you look at 2x plus 5 equals 11, you can see that it's written in the same form as ax plus b equals c. So it's very easy to see what numbers represent what letters. In the second equation, the 2 is the a, the 5 is the b, and the 11 is the c. So we go back to our literal equation, and to solve it, we're going to isolate x on the left-hand side. So we're going to subtract b from both sides so that we get ax equals c minus b. When we divide by a, we get x equals c minus b divided by a. To solve for x now, we substitute the values that we looked at in 2x plus 5 equals 11, and we take those and substitute it into the equation we just learned. So we're going to take these values here, and we're going to bring them down and substitute them in. So we get x equals 11 minus 5 divided by 2. That's 6 divided by 2, and that equals 3. It's important to note here, whenever you have a variable in the denominator and you're solving a literal equation, you can assume that the variable is not equal to 0. Because remember, when a denominator is 0, it means the fraction is undefined. When you have two or more variables, you can always solve for one in terms of the other. So you can always pull one of the variables over to the left-hand side by itself and solve for it. Whenever you see this, y as a function of x, that means y is on the left-hand side of the equation and x is on the right. In other words, x is the independent variable and y is the dependent variable. What you set for x determines what y is. Y depends on x. This is called function form, and I know you've seen function form before. Some really famous function form equations, especially this one, is y equals mx plus b, which is the equation of a line. Okay, you can see this follows function form because y is on the left-hand side by itself, and the value of y is determinant on what the value of x is. So you can rewrite any equation so that one variable is a function of the other. It just means that one variable will be on the left-hand side. In example 1, we're going to rewrite 3x plus 2y equals 8 so that y is a function of x. That means the y's need to stay on the left-hand side. So we're going to subtract 3x from both sides to get 2y equals negative 3x plus 8. And then we'll divide both sides by 2. So negative 3 halves x times x plus 8 equals y. Okay? Once you get it in that form, oftentimes they'll give you a value for x, and you'll plug it in and calculate what y is. You should try example 2. I have 3/4 x minus 6y equals 12. Try to write that in the function so that y is a function of x. Y is a function of x, so remember what that means. Bring y over to the left-hand side and everything over to the right. Pause this recording, right? Pause it for a minute and just try to do that on your own. The first thing that I would do is subtract 3/4 x from both sides. So I'm going to have negative 6x equals negative 3/4 y, x, take that back, negative 3/4 x plus 12. Then you need the y by itself. Watch out with the negatives here. You're going to divide both sides by negative 6y. So we have y equals negative 3 over negative 24 x. And when you take 12 and divide by negative 6, you get negative 2. You have to make sure you reduce this fraction, right? This should be 1/8. And it's minus 2. So now you have y as a function of x. It's an equivalent equation. It's just written in a different form. That first form that you actually saw right there, that's called standard form. Okay? We talked about that a little bit in class, and we'll see it a lot later in the book. But standard form is used for a lot of things that we actually haven't gotten to yet. So we'll take a look at that later. That's called standard form when you have x's and y's on both sides. Once you can write any equation as y as a function of x, you can solve any kind of equation at all, especially geometric formulas. The book talks about all kinds of areas and volumes of different figures. So we take a look at volume that you know, the volume of a rectangle or a square. V equals L times W times H, length times width times height. To solve for H, you just divide both sides by LW. So now we have volume divided by LW equals H. So I could give you numbers for volume, length, and width, and you could tell me what the height of the figure is. Along the same lines, area equals length times width. So if we wanted to solve for width, we just divide both sides by length. So you get area divided by length is width. The area of a triangle is 1/2 the base times the height. This is a little more complicated because to solve for h, you have to multiply both sides by 2 to get rid of that 1/2 fraction. So you get 2a equals bh, and then divide both sides by b. So you get 2a divided by b equals h. And once you solve these for a certain variable, you can substitute any values in. So I could give you any dimensions of a figure, and you should be able to plug it in and solve for the variable we solved for. Okay, so let's take a look at this example. If the area is length times width, then we know length equals area divided by width. So if I give you the area of a rectangle is 100 centimeters squared, and the width is 25 centimeters, you should be able to solve for the length. You're going to substitute 100 for A and 25 for W and solve for L. So you should get that the length is 4 centimeters. Don't forget your units there. With temperature, you're always going back and forth in science with temperature, converting Celsius to Fahrenheit and Fahrenheit to Celsius so that you can have consistent data across the board. So we know that the Celsius formula is C equals 5/9 F minus 32. But if you had to solve for F, the first thing I would do is multiply by the reciprocal of the fraction so that you get 9/5 C equals F minus 32, and then add 32 to both sides. So given any Celsius or centigrade temperature, you should be able to find Fahrenheit. So why don't you try this? Okay. When it's 25 degrees Celsius, what is the Fahrenheit temperature? Take a second and pause this, and then you can see what I do. I'm going to take 9/5 and multiply it by 25. And then I'm going to add 32. And that should be my Fahrenheit temperature, right? So 9/5 times 25 is 45, I believe. Right? 9 times 5. And then we're going to add 32. So the temperature is actually 77 degrees. Okay? So it's really simple once you have the formulas written in terms of the variable that you want to solve for. It's much easier than substituting when things are all in the wrong order. So whatever variable you want to solve for, get it on one side, write it in function form so it's on the left-hand side, and then you'll be able to solve given whatever value.